Next we have the types of electrode. The types of electrode, here we are going to learn the different types of electrode, and these electrodes are classified on the basis of how they are kept, how they are arranged, or how they works during the electrogenesis, I can say. So here the first type of electrode which we have is a metal ion electrode. Metal ion electrode. The metal ion electrode is the one where the metal electrode is placed in a solution containing the same metal ion. For example, here I can say that suppose this is a zinc electrode. Let there is a zinc electrode which is placed in a solution of the same metal ion. That is, this is zinc electrode and the solution is containing zinc ion solution. That means the solution may be zinc sulfate solution, or it may be zinc chloride solution, or zinc fluoride bromide solution. That means the solution should contain zinc. So here this is an example of metal ion electrode. So where the metal electrode is placed in a solution containing the same metal ion of which the electrode is made up of. How it is represented? Generally for the representation of a single electrode, we write ions first and then we write the electrode, or we can write electrode first or ions later. But here we are going to follow a single rule. For writing a single electrode, we will write ions first and then electrode. I am talking about writing a single electrode. So here this full half cell will be represented as the zinc ion in aqueous medium. If you know the concentration, then you have to write the concentration, and zinc electrode, that is in solid state. So reaction, either it is going to be oxidation or reduction. So zinc 2 plus 2 electron will give you zinc. When we write in this manner, that is zinc ion and zinc, then we generally write it's a reduction reaction. And if you are writing zinc first and then zinc ion, like if you are writing zinc and then Zn2 plus, then generally we write it as an oxidation. That means the zinc will be considered as a reactant and the zinc ion will be considered as a product. But since we are considering this one, so this is the proper reaction for it. Similarly, I can say another reaction is, another electrode is Pb2 plus and Pb. That is a lead electrode which is placed in a solution containing the lead ions. That is a Pb which is placed in a PbCl2 or PbCl, lead nitrate or lead sulfate or lead phosphate. So here I can say again the reaction will be reduction reaction, Pb2 plus 2 electron, which gives Pb. Similarly, I can say another example like Cu2 plus in aqueous state and then Cu in a solid state. So reaction will become copper ions which gains electron and produces copper. So this is the first type of electrode which is known as a metal ion electrode. Now let's see the second type of electrode. The second type, non-metal ion electrode, which is also known as gaseous electrode or gas electrode. So non-metal ion electrode, as I said, it is also known as a gaseous electrode. Now it is an electrode where I can say that gas is passed through a solution containing the same ions of which the gas is made up of. While talking about the cell reaction, means when we were writing the cell representation, during that time there was an electrode which was made up of hydrogen or chlorine. That means where we were passing the hydrogen gas through the H plus ion solution. So that hydrogen gas electrode was nothing but the gaseous electrode. So it is something like this. It is a solution. Suppose I wanted to write hydrogen gas electrode. From here we will pass hydrogen gas, and there is an electrode. Now in this case, the electrode which is used is an inert electrode. Here the electrode itself is taking part in a reaction, but in the case of this non-metal ion electrode, the electrode is an inert. So here this is the solution of suppose H plus ion, and if the solution is containing H plus ion, then in that case you have to pass the same hydrogen gas, and if you are passing a hydrogen gas, the dry hydrogen gas you have to pass, and so and if we are using a gas, then we should know the pressure on the gas. So it is under 1 atmosphere pressure. So the first example I can say hydrogen gas electrode, it is called. This example is hydrogen gas electrode. Hydrogen gas electrode, how it is represented? First, I will write H plus ion in aqueous medium. Then generally after the ions the electrode comes, but as I told you during the representation while explaining this, that if there is any particular gas or if there is any salt which is taking part in a reaction, then you have to mention it between the ion and between the electrode. Here, as I said, the platinum being a inert electrode, it will not take part in a reaction. So here in reaction the H plus ion and H2 gas are involved. So here hydrogen gas is very important for us. So you have to write the hydrogen also, you have to in a representation, and since it is a gas, so you have to write its pressure, and then platinum, that is the electrode. Now the reaction is taking place between H plus and H2. So how it is, the reaction will be H plus will gain electron and will give you H, but as we all know, hydrogen never exists in a monoatomic form. So for diatomic, there is a 2H plus ion will gain 2 electron and gives H2 gas. And so this is the hydrogen gas electrode. The another example, chlorine gas electrode, in the same way I can say the chlorine gas electrode. Chlorine gas electrode the same way, there is a chlorine ion inside the solution, and so we pass chlorine gas, and whose pressure is to be mentioned, that is a pressure of chlorine gas, and then platinum, again an inert metal. Being a negative charge, I had already told you that you have to, while writing a reaction, you have to consider in the reverse manner. Generally, this is the reactant, this is product, but here since it's a negative charge, so you have to consider this as a reactant. So Cl2 will gain 2 electron, and then only you will get 2 Cl minus. So this is chlorine gas electrode. After chlorine gas electrode, that means after the second type of electrode, that is a non-metal ion electrode, third type which we have, metal sparingly soluble salt electrode. Metal sparingly soluble salt electrode. Now let's see how it works or how it is arranged. For metal sparingly soluble salt electrode, we consider an electrode. I'm considering here the silver electrode. The silver electrode which is placed inside this. Now the rule says that this metal electrode should be coated with the salt of the same metal ions which are sparingly soluble in the solution. Sparingly soluble, that is a very slightly soluble in the solution. So suppose if this is a silver electrode, if this is a silver electrode, then this silver electrode is coated with a salt of silver, that is a salt of same metal electrode, the ions of a metal electrode which is sparingly soluble. So here I am just coating it with the salt of silver. So this coating is of AgCl. So the first condition is that the electrode should be coated with the salt of the same metal ions, the same metal electrode ions, and which are sparingly soluble. And it should be kept, these electrode coated with the salt should be kept in a solution which is containing the same anions which is present in a salt. So here the solution in the solution should contain the same anion which is present in a salt. So salt is containing chlorine ion. So this solution should contain Cl minus ions. So here the solution should contain Cl minus ion solution. So it's a 1 molar Cl minus ion solution, I can say. So now here the reaction takes place between the chlorine ion and between the AgCl. Ag is get coated with the salt. So now here there is a contact between the AgCl and the solution, that is a salt and the solution. So reaction takes place, that is between the AgCl and Cl minus. Now representation, the first you have to write the ions which is from the solution, that is a Cl minus, which is coated, and then generally after the ions the metal comes, but electrode comes. But as I said, there is a AgCl which is taking part in a reaction, so you have to write this salt also, and then Ag electrode, that is a silver electrode. Okay, now the reaction is going to be, as I said, the reaction takes place AgCl and Cl minus. So AgCl will gain electron and produces Ag plus Cl minus. So this is the reaction, that is AgCl plus electron gives Ag plus and Cl minus. So this is the first example for the metal sparingly soluble salt electrode. We have one more example, that is Cl minus G2Cl2 salt, and then mercury electrode. That is a mercury electrode which is covered with the salt of the mercury, that is Ag2Cl2, and it is placed in a Cl minus ion solution. Generally the Cl minus ion solutions are nothing but the saturated KCl solution, right? So here how to write this electrode have a one particular very important name, that is called as calomel electrode, and about this electrode we are going to learn in a detail in the same chapter, that is a calomel electrode. So this electrode is a calomel. Now it is calomel electrode is considered as an example of metal sparingly soluble salt electrode. So now the reaction, that is Ag2Cl2 will gain 2 electrons as there is a 2 chlorine, and it will produce 2 Hg plus 2 Cl minus ions. After this, so we got the third type, that is a metal sparingly soluble salt electrode. Then fourth is the fourth type is redox electrode. Now what is redox electrode? The redox electrode is the one, I can say, where the solution contain the same metal ion but with a different valency. And again in this case also, like non-metal ion electrode, in this case also the electrode is inert in nature. Means here also I am using a same platinum metal which is inert metal. So for the redox electrode, this is the platinum electrode, and as I said, the solution contain the same metal ions, like the solution is containing FeCl2 and FeCl3, and if the solution is containing a mixture of FeCl2, then FeCl2 will dissociate to produce Fe2 plus, and FeCl3 will dissociate to produce Fe3 plus. That means I can say that the solution is containing a mixture of the same Fe ions but with a different valency, that is a 2 plus and 3 plus. And here, since the valencies of these metal ions are different, so the reaction takes place between these two metal ion itself. And being inert in nature, the platinum electrode does not take part in a reaction. So now let's see how it is represented. So first example, the same, Fe2 plus in aqueous medium, Fe3 plus in aqueous medium. Both are in the same state or the same phase. Therefore there is no need of using that vertical line. And then platinum, As I said, the reaction takes place between these two. So if I have Fe3 plus, we are writing reduction reaction. So Fe3 plus will gain 1 electron and will give you Fe2 plus ion. Similarly, I can say another example. A solution which contains the copper ion in a cuprous form as well as in a cupric form, that is Cu2 plus and Cu plus, aqueous and copper in solid state. Then here I can say that the reaction will be Cu2 plus 2 electron, plus 1 electron will give you Cu plus. So the reaction takes place between the two metal ion only. So we have overall 4 types of electrode. That is, the first one is a metal ion electrode, non-metal ion electrode, which is also known as gaseous electrode, where we pass a gas. The gas and solution contain the same ion of the solution contain the same ions. And then metal sparingly soluble salt electrode, where a metal electrode is coated with the salt, sparingly soluble salt of the same metal ion, and it is placed in a solution which contains the same ion which is present in the salt. And then redox electrode, where the electrode is again inert in nature. And in this case, solution contain the metal ions with a different valency. So these are the 4 types of electrode which we have.